Welcome to a lesson with Dr. Powell. Let's take a look at a partial fraction decomposition problem. What if we had something like x plus 2 squared and maybe x minus 1? Okay, how do we integrate this? Well, we're going to first partial fraction decompose this using kind of our setup that we have. We know this is going to be of the form with an x plus 2 squared and an x plus 2 and just an x minus 1. Now, what goes on the top of each of these? Oh, this be like all of these, notice, will be constants. So because a constant on the degree 1 means a constant as we go up as well. So we could just put A, B, C, and we're set on our way. So now we just have to figure out what A, B, and C are. We know that when these add up together, we're going to have 1 over x plus 2 squared times x minus 1. Now, one quick way of doing this, first of all, we can circle the highest powers. And this method works when we have only when we have linear things, when we have things raised to a power like x plus 2 squared, where this is not a quadratic in here before it's squared. So it's just x plus 2, kind of an x minus 1. So this particular method will work. Pick the highest degrees of each, so 2 and this, and then what we're going to do is we go over here and we think in our minds of just kind of covering things up a little bit. So for a minute, let's pretend that, let's try to find C. So let's pretend that x minus 1 doesn't exist. Then if it doesn't exist, then what would happen if you were to plug in 1? I mean, if you plugged in 1 here, it would blow up, but now it's gone, so you can plug in 1. If you plug in 1, you'll get 1 over 3 squared, which is 1/9. That actually means that C is 1/9. Okay, now let's put x minus 1 back in the ranks again. And let's pretend that this doesn't exist, so we can plug in -2. Now, if we were to plug in -2, we would get 1 over -3 right here. So that's what A is. So, so we'd have -1/3. Now we just need to figure out what B is. Okay, so this is back in. How do we figure out B? So since we already have A and C, B shouldn't be too hard to figure out. Let's just put it in right here. Because you know that this actual equation is an equation between expressions with x, meaning that it's true for every single value of x that works in the domain. So let's just pick a value of x. So we actually got these guys from values that weren't in the domain of the expression. And we can explain why that works at another time. But right now, let's focus on the method and how we could actually find this B. So just plug in something else, just not -2 or 1, but something rather simple. Why don't we just try plugging in something like, or I say we don't want 1 or -2, that is. But what if we tried plugging in something like -1? -1 works. Okay, we can plug in, or 0 if we wanted to. See, would work too. Yeah, why don't we do 0 or -1? I'm trying to think. yeah, I guess it doesn't really matter. Zero is fine. So if you plugged in 0 everywhere, notice that we would end up having negative a third divided by 4, but you could just put that in the denominator, plus b divided by 2. And then you have plus, let's see, what are we doing? 0. So a ninth divided by negative 1. So that's really just minus 1/9 equal to, then we could have 1 over 4 times negative 1. So negative 4. Okay, so then what we could, okay, so then this is great. Why don't we multiply everything by 2? Why don't we multiply everything by 2? In this, so we have negative 1 over 6 plus b minus 2/9 is equal to negative 1/2. Okay, then you can put these on the other side, and thinking about this, it looks like be 36. Yeah, okay, so we could do 30, right? So if we multiply, right, so let's just think about that, just adding fractions. Common, yeah, or 18 actually, yeah, 18 would work. So adding fractions, getting the same denominators. So what we could do is we could say this becomes let's see, so that would become negative 3 over 18 plus b, let's see, minus 4 over 18 is equal to, and let's see, negative 9 over 18. And then you can just, okay, so negative 7 and plus 7. So it'd be what, negative 2 over 18 would be b, or in other words, b would be negative 1 over 9. Okay, so if b is negative 1 over 9, we have just successfully decomposed this. All right. So without too much hassle, kind of the steps were, again, over here, we did kind of a cover up. We did a cover up thing in order to find the a and the c, covering up that factor or that factor and plugging something in that would have made that 0. And then we were able to get these, and these. Okay. And then after we were done with that, we just plugged in anything we wanted to in here into this equation that went to here, or maybe right here, to solve for the remaining value of b. Now, in general, you can do that. You could just keep on plugging in values until you have different equations where you can solve. That's a nice method and a nice way to go. Okay, so we get these things, and then in the integration, why does this help integration? Well, let's think about this. Think about this first guy. This is like u to the negative 2, where u would be x plus 2. So we're integrating something to the negative 2. Integrating that would be that thing raised to the, you add 1 to the exponent, so negative 1. And then you divide by the new power, which is negative 1. And then you have to divide also by the derivative of this linear guy, which is just 1. So we're good to go there. And then we just multiply by negative a third. This part right here, you can factor out the negative a ninth kind of out of that integral. And it's just, this is like 1 over u, and with u substitution, but the derivative is just 1. So it's really nice. It's going to be the natural log of x plus 2. And this next part, very similar, plus a ninth times the natural log of x minus 1 plus c. And then we are completely done. Thanks for watching.